Hello everyone. So in this section, we're going to be covering section 8.1b, right triangle trigonometry, and we're finally going to know what those buttons, sine, cosine, and tangent, what those buttons are used for on the calculator. So anyways, in the previous section, what we ended up doing was we used Pythagorean theorem. So if we had like two sides of a right triangle, we could always figure out what the third side is, whether we had the hypotenuse or one of the legs, or whether we had one of both of the legs. In this section, if we, it's going to be a little bit different. This time, we're only going to be given one side of a triangle, and we'll also have one of the angles. And based off of just those two pieces of information, we can figure out what any of the other sides are. And that's essentially what we're going to use. That's where sine, cosine, and tangent come into play. So the most common phrase, and probably something you're going to end up repeating a lot in your during this time, is you're going to end up using the phrase so, ka, toa. All right. Say it a few times, write it a few times. Some teachers, have their own mnemonics that they like to use. Like I know if you have hurl or me in the past, we used to use the phrase some old hippie caught a hooker tripping on acid. You pick the way that works best for you. All right. I want to keep this video a little bit shorter, so I'm going to go ahead and just leave it simple as so katoa. So what does this stand for? Obviously, if I look at S is going to stand for sine, C for cosine, T for tangent. Now the O is represents opposite. The H represents hypotenuse. A represents adjacent. There's H again, hypotenuse. O represents opposite again. And A stands for adjacent. All right. So whenever you want to set up anything that has a sign, what you're going to end up thinking is remembering the phrase opposite value divided by the hypotenuse value. These are the sides of the triangle. And essentially what you're going to be doing is you're going to be taking the sine of some kind of angle next to it. The cosine of some kind of angle next to it, or of the angle of interest that you're looking at, is going to be the adjacent side divided by the hypotenuse side. The tangent is the opposite over adjacent. All right, so I wanted to go over this phrase first so that you can kind of just, see how we actually set this up, and that's when I'm going to come up here. So it says over here, let's say I wanted to figure out, and I have this triangle right here. This is angle A, B, and C, and I'm looking at the sine of angle A. So again, you have to remember the phrase opposite over hypotenuse. Okay, let me get a different color here. So let's say I'm looking from the perspective of angle A, okay? Now you got to ask yourself, okay, I have these different parts of the triangle, and from the perspective A, okay, the side that's opposite of that angle is going to be little a. So little a, that's this side right here. And then the hypotenuse of this triangle, it's always the one that's opposite of the 90-degree angle. So it's going to be little a divided by C. Okay? Now, if I wanted to figure out what is the sine of angle B now from the perspective of angle B, the sine of that is going to be the side opposite of this angle now. So side B divided by the hypotenuse C. Okay, so really the only hard part about this chapter, if you even want to call it hard, is just looking at the triangle and deciding, well, from my angle, which one is opposite, and the hypotenuse and the adjacent, and so on and so forth. And then once you figure that out, you're pretty much good to go. All right, now let's think about cosine. So if I think about the cosine of angle A, okay, well, we know that little a was opposite of that. Now, if you guys remember what the phrase adjacent means, that means next to, right? So now you got to look at, if I want to figure out what the cosine of A is, so I got to figure out which sides are adjacent, and then obviously the hypotenuse is still C, right? But which side is adjacent? Well, here's the thing. There are two sides that are right next to angle A, right? But if we already established that this is the hypotenuse, what they're talking about for the adjacent is the other one. So it's actually B divided by C, okay? And then same thing over here from the perspective of this angle B, cosine of this angle, all right? Obviously, there are two sides next to it, but we already said that C is the hypotenuse, so A is adjacent to that. So A divided by, and it's adjacent over hypotenuse, and the hypotenuse we already established was C. All right, and that's it. That's pretty much the setup of the whole thing. So now if I look at the tangent of A, all right, So now I'm going to go back to to the perspective of angle A. So from angle A, which side is the sides that we're interested in, the opposite side and the adjacent side? Well, opposite of angle A is little a. So I have little a right there. And then adjacent to that, well, between B and C, those are next to it, but B is the one that's adjacent because C is the hypotenuse. So it's A over B. And then if I think about it from the perspective of angle B, so from angle B, opposite of angle B is little b, and then adjacent is little a. Okay? And then once you get the setup, everything else is just plug and chug, work in your calculator, and so on and so forth. Let me go back to my purple color. All right. So that's what we're going to end up doing to solve these problems. So when I have my right triangle and and they say, okay, we'll find the missing side, and they give you an angle and one of the sides of this right triangle. This is all right triangle, or this is all only relevant to right triangle, everything that we're doing, okay? So anyway, I'm going to look at my angle 28 degrees, okay? And I'm going to go ahead and what I like to do, and I tell students, I mean, some students can do this intuitively. I always tell my students, hey, make sure you label the parts of your triangle, because that's going to help you decide which of the three trig functions you're going to use. So if I look at this right triangle, I'm going to say, okay, well, from the perspective of 28 degrees, obviously 19 is always the hypotenuse. Opposite of 28 degrees is O. And then over here, adjacent is this one right here. So now I'm going to go ahead and say, okay, well, now that I have labeled the parts of my triangle, now I'm going to say, okay, well, which parts of the triangle do I have and what am I looking for? Well, obviously I have the hypotenuse and I have the opposite, right? So now you got to think backwards and say, okay, well, if I have the opposite and the hypotenuse, which of my three trig functions, sine, cosine, or tangent, has those two values? Well, the sine does. Sine has opposite and hypotenuse. So what we're going to end up doing to solve this problem is we're going to go ahead and take the sine of 28 degrees. And the setup is really simple. I have sine of my angle, 28, is equal to, and then opposite, so opposite over hypotenuse, x over 19. Okay? And now it's just a matter of solving for x right now. So I'm going to go ahead, and what I'm going to do is I'm going to put this over 1, and then I'm just going to cross multiply. So cross multiply, I have x times 1 is x. Sine of 28 times 19, well, that's going to be 19 times sine of 28, right? And this is where the calculator comes in handy. Now, I'm at home right now, and this is the only calculator I have, so it's a little bit fancier than what you're used to, but it's the same thing. I'm going to take the sine of 28 degrees. Wait, hold on. Let me make sure I'm in degree mode. Sorry. Let me go back. So it's going to be sine of 28 degrees is that number times 19. And that gives me 8.92. So x is equal to 8.92. All right. And it's pretty much a similar setup right here. So now, again, from the perspective of this angle right here, okay, let's label the parts of our triangle. So I look over here and I know that this side of the triangle is the opposite. I know that this one, opposite of the 90-degree angle, is the hypotenuse. And then obviously this next one, what's left is the adjacent. Okay? So then I look to see, okay, well, what parts of the triangle do I actually have? Well, there's the hypotenuse area is blank. My x is with my opposite. 32 is with my adjacent. And now I say, okay, well, I have opposite and adjacent. So which of my three functions has opposite and adjacent? TOA, opposite over adjacent. So I know that I'm going to be taking the tangent of the angle. Remember, when the number that you put or that you use the trig functions for, you're taking the trig function of the angle. So let me set this up. It's going to be tangent of 41 degrees is equal to opposite over adjacent. So x over 32. And that's the setup. Right? Now it's just a matter of putting this over 1, cross multiplying. X times 1 is x. Tangent of 41 times 32. So let me write it out. Tangent of 41 times 32. So tangent of 41 times 42 gives us x equals 36.51, right? I don't know how many, oh, to the nearest hundredth. Okay, so 2 decimal places, good. All right, now let's look at this example, and then I'm gonna go over some more of the problems in the back. So if I, again, from the perspective of this angle right here, all right, this is gonna be a little bit different, but you just have to do one extra step. If I think about the angle 37, what parts of, let me label the parts of the triangle. So I know opposite of that is over here, the hypotenuse is opposite of the 90 degrees, and then what's left is the adjacent, right? So now I'm going to say, okay, well, which parts of the triangle do I actually have labeled? I have a hypotenuse, or I have something in my hypotenuse, and I have something in my adjacent, okay? So adjacent and hypotenuse, okay, that would be cosine. That's the one, the trig function that has both of those values. So I'm going to set this up. I'm going to have cosine of 37 degrees is equal to adjacent 24 divided by the hypotenuse x. All right. Now this time when I cross multiply, I'm going to have x times cosine of 37 is equal to 24 times 1. All right. Now we just have to do the extra step of getting x by itself. So we're dividing both sides by cosine of 37. It's nothing that much drastically more different than what we did before, except now we just have x is equal to. So now I'm going to do 24 divided by the cosine of 37, and I get 30.2 decimal places, 0.5. So 30.05. Okay. So this front page just kind of goes over the basics of how to set things up, and then on the back page we're going to go ahead and do some word problems. All right, so if we go into the back part of the page, essentially now we're just going to go ahead and create the triangles ourselves based on the word problem that's in front of us. So it says over here, Jake leaned on a 12-foot ladder against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? All right, so I'm just going to draw a house here. It's probably the ugliest house I've ever seen. Maybe a little window there, whatever. And then there is a 12-foot ladder. Let's put this ladder here, right? That's 12 feet. This is a very unrealistic length of a ladder compared to the house, but whatever, just follow along. So it's a 12-foot ladder against this house, and then it says if the angle formed by the ladder, so then in the ground, so we're going to draw the ground here. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place? So essentially they want to know how far from the base of this house and the bottom of the ladder, did he place the ladder? So anyway, so right there you can immediately see, and obviously that's going to be a right angle right there. You have a right triangle with basically two parts of it filled out, and we have our angle right there. So if I label the parts of the triangle, well, obviously I know that this is the hypotenuse, right? Opposite of the 68 degrees is out here, and then adjacent would be the one next to it that's not the hypotenuse, right there, right? So I go ahead and I look at this and I circle the parts of the triangle that are actually labeled. We have the adjacent and the hypotenuse. Now, again, every time I know I'm going to be doing trigonometry, I just always write it at the top of my paper. So, ka, toa, right? It's an easy enough phrase to remember, and it's quick to write. And then that way I can say, okay, I have my A and my H. I'm definitely going to take the cosine of that angle. So then that's pretty much what you do. So I take the cosine of 68 degrees is equal to adjacent over hypotenuse, so x over 12. And this is one of the easy ones where I just have to multiply the 12 with the cosine of 68. So if I cross multiply, I have x is equal to 12 times cosine of 68, which, let's go ahead and turn my calculator back on. 12 times the cosine of 68. And I have 4.95, 2 decimal places. So 4.50. My bad. I don't know why I struggled with that. But anyways, now I'm going to look at the next two examples. All right. So that's how far away the bottom of the ladder is to the base of the house. So now if I look at these other two examples, this is a little bit different now. Now the angle is not given to me, but they do give me two sides. And what they're essentially going to ask us for, I mean, it doesn't say anywhere in the directions, but they say, find the value of x, right? So obviously the x is the angle, but you're still going to be using trigonometry to answer these problems. So if I look at angle x, again, I'm still going to label all the parts of my triangle. Here is the opposite. The hypotenuse is this one. And then I have 37 that's next to the x, but not the hypotenuse, right there. So once I've labeled the parts of my triangle, I know I have my adjacent. I know that I have my opposite. So when I look at SOHCAHTOA, O and A, that goes with tangent. So I'm going to take the tangent of this unknown angle x is equal to the OA, O over A, so 20 over 37. All right. So what you'll end up with here, right, is you'll end up with the tangent of x is equal to some decimal. If I did 20 divided by 37, I end up with 0.54054 repeating. So 0.54054 repeating, right? But the thing is, how exactly do you get tangent by itself? Now, I know if you usually see some number times a value of x, right, you would divide that number and you get your x by itself. When it comes to the trig functions, in order to get your x by itself, you'd have to treat it a little bit differently. In order to, like if you had like 3x is equal to 9 over here on the side. In order to negate the multiplication, you divide, right? The inverse operation of multiplication is dividing. Well, I don't know why I canceled that 3. So x is equal to 3. But the inverse operation of tangent is going to be inverse tangent. So now, and this is true, and this is how it is on most calculators. See how in that tangent button above it we have inverse tangent, right? So what I'm going to do, I'm going to click second inverse tangent of whatever my decimal is. And the thing is, what you can do is you can just go ahead if you want to just retype that previous number into that. You're going to press second answer, right? And I know this calculator looks a little bit fancy, but if you have one of those blue Casios, it works the same way. But if you have, so that means x is equal to 28.39. This is why I wish I had one of these calculators at my house. But if you have one of those other calculators, like the black ones that say TI30XA on the top, what you would do instead is you would have the number. First, you do all of your math when you end up with your number, and then you press second inverse tangent. You kind of do it the reverse, right? All right, so for this next problem, I'm going to go ahead and look at this triangle, and I'm going to label this triangle again. So I have x, opposite of that is over here. The hypotenuse is always opposite of the 90 degrees, so there's the hypotenuse. And then the adjacent is that 8 right there, okay? So now I'm going to circle the values that I have. I know I have my adjacent and my hypotenuse. So which one corresponds to that? The cosine, right? That cosine has the adjacent and hypotenuse. So I'm going to take the cosine of angle x, set that equal to the adjacent over the hypotenuse. I have 8 over 11. Okay. So I'm going to do 8 divided by 11, right? I have my decimal. Sorry, there it is. I have my decimal, and if you have the TI30XA from your decimal, you're just going to press second inverse tangent, and it'll do it automatically. If you have one of these other calculators, I'm going to do second inverse tangent, then I have to retype my answer, so I'm going to press second, then answer. All right, so I take the inverse tangent of my previous answer, and then I have 36.03 degrees. So x is equal to 36.03 degrees. All right, not too bad. So now I'm going to go ahead and look at example 7. I think this is another one where you have to find the actual angle as opposed to like a side of the triangle. It says Jaden is flying a kite and lets off 275 feet of string. So here's Jaden, right? Flies a kite. Not a bad kite at all. All right, but anyways, he lets off 275 feet of string. If the kite is 150 feet above the ground, so let's just say that this is the ground right there. So the kite is 150 feet above the ground, and assuming the string is straight, so the string is straight, what angle does the string make with the ground? So they want to know, what is this angle right there? You can call it theta. We'll just go with x because that's what we were using before, right? So from here, I'm going to go ahead and say, again, I'm just always going to label my parts of my triangle. I don't care how smart you are. Sometimes it's just helpful to do it. Opposite of that is here, the hypotenuse. So that's 90 degrees right there. And that opposite of that is the hypotenuse. And then adjacent is the one next to it. That's not the hypotenuse. And so I'm going to circle the values that I have right there. So I know I have an opposite and a hypotenuse. So in SOHCAHTOA, opposite hypotenuse, there it is. I'm going to use the sine. So sine of whatever angle I want is equal to opposite 150 divided by the hypotenuse 275. All right, so I'm going to go ahead and get the 150 divided by 275. Oh, 54 repeating. So, and then in order to get x by itself, so I have sine of x is equal to 0.545454, whatever, right? You don't have to write this step. If you just want to go straight, as long as you have the right setup, and then you have the, you just do everything straight from your calculator. I know I'm going to take the inverse sine to get x by itself. I'm going to take the inverse sine of both sides. Inverse sine of that answer. And I get, my angle is 33.06 degrees. All right, so that was a longer set of notes than I was really hoping for, but this is a very important topic, and it's a guaranteed question on the FSA. So we got to make sure we start thinking ahead because we're getting closer and closer to it. So hopefully this was helpful. Hopefully my random edits to the video doesn't distract you, and hopefully my stuttering doesn't distract you. But either way, if you have any questions, you're more than welcome to ask me anything you want. Any of your geometry teachers, we are all pretty darn competent. So I'll let you guys go. Have a good one. Take care.